So today we will discuss the normalization chapter from DBMS and how many kinds of normalizations are there, why it is needed, that things we will discuss. So what are the objective of normalization? So normalization is a technique of decomposing a relation into smaller relations based on the functional dependency to remove the anomalies and remove the redundancy or minimize the redundancies. Okay. So we have actually normal forms like first normal form, second normal form, third normal form, fourth normal form, fifth normal form, DKNF, Dominican normal form. Those are there. But today we will discuss up to BCNF. So already we have discussed that normalization removes the redundancy. So then what is the advantage of this? So redundancy creates multiple copies of same variables. So in order to remove that one, so memory will be less if redundancy is removed. So under this fast normal form, what it actually tells, a table is said to be in fast normal form if the domain of each attribute contains only atomic values, means single value, right? So each cell contains only a single value. So this is the idea of fast normal form. We cannot have any repeating values under this. Fine. So one of the example is here. Suppose for a library system, patron ID is C45, C12, the first column of the picture. Second one is borrowed books are under this first row. We have the B33, B44, B55 as the data. It is written in comma form. And under C12 row, it is having B56, right? So here, since patron ID C45 contains three values, three multiple values, that's why it is not in fast normal form. So what we will do, we will convert that into fast normal form because C45 has got B33, B44, B55 values. So we will split that. C45 is B33, then C45 is B44, C45 is B55. So this is the solution, fast NF solution. So here each cell contains a single value. That's why it is in fast normal form. Previous one was here unnormalized form. It is not in normalization form. So now it becomes a fast normal form because fast normal form means each row, each cell contains a single value. So now it is in single value. Previously it was multiple values. This is also another example for an airline flight and weekdays are two columns. Under this, we have the data UA 59 and UA 73. Under weekdays, we have three values MO, WE, FR, MO, Monday, Tuesday, Wednesday, Thursday, Friday, like that. So that's why it is in unnormalized form. So we have to convert that into normal form. So this is the normal form, fast NM solution. So those are repeated. We have written it multiple times. Okay. So this is now becomes in fast normal form. So it is implicate in we can implement it in ER model, like the watch for entity that can have multiple values for the same attribute. Okay. Then this is the idea. So then we will have the functional dependency. This concept is required in normalization because normalization is based on totally on functional dependency because so what is that functional dependency? If X and Y be two sets of attribute in a table T, then Y is functionally dependent on X if or for each set X belongs to R dot X, there is precisely one corresponding set of Y belongs to R dot Y. It means that if there are two attributes X and Y, so X determines Y, means the values of X have unique values in the y set. Okay. So in second, we can tell that, we can say that y is fully functional dependent on x if if y is functional dependent on x and y is not functional dependent on any proper subset of x. Fine. So one set x and y are two attributes. X has got many values, y has got many values, but each value of x is uniquely associated with a single value of y in a single value of y column. Fine. So this is the idea of functional dependency. So this is the book table, book number, title, author, year. Then these are the rows, available values are there also. So author attribute is your functional dependent on the pair book number title. Okay, functional dependent. Why? Because it is unique value. It is producing the unique value. Then fully functional dependent on book number. Book number, it will be fully functional dependent. Fully functional dependent one means uh, it is all the proper subsets are not producing any unique, but combinedly it is producing the unique. So it is also similar to that. Here, what happened here in the same way it is written. Another example this is. So we can go through that. Then what are the problems occur while we are producing the normalized form? It cannot insert new patterns in the system until they have borrowed books. So it is called insertion anomaly. Must update all rows involving a given pattern if he or she moves. This is called update anomalies. Will lose information about patterns that have written all the books they have borrowed. This is called deletion anomalies. These problems may arise while we are doing the normalization. So there is a Armstrong inference rule. It is developed in 1974 by Armstrong. So axioms are like this. One is reflexivity, augmentation, transitivity. So what is reflexivity? Reflexivity means if y is subset of x, then x determines y. Augmentation is if x determines y, then w will be multiplied to both sides. It is appended with x and appended to y in the right hand side. So wx determines wy. If x determines y, then wx determines wy. Transitivity means we know that if A is related to B is related to C, then A related to C. This is a mathematical concept. It is also utilized in functional dependency. That is here written, if X determines Y and Y determines Z, then X determines Z. Then few rules are there, derived rules. It is derived from, these are derived from axioms of Armstrong. First one is union. If x determines y, x determines z, then x determines yz. So right hand side will be appended. Decomposition, if x uh, determines yz, then x determines y and x determines z. Decomposition means it is decomposed into two parts. Pseudo transitivity, if x determines y and wi determines z, then xw determines z. And Armstrong axioms are both sound and complete. So when applied to a set of functional dependency, they only produce dependency tables that belong to the transitive closure of that set. It can produce all dependency tables that belong to the transitive closure of the set. So these are the few rules. Union rule is x determines y, x determines z, x determines yz. Three last rules, it is actually derived from the axioms. Another is x determines y, x determines xy. Xx means it is here x union x, that is x determines xy. If x determines z, then yx determines yz. Y will be multiplied to both sides, appended with union value. So xy determines yz. Third one is x determines xy, xy determines yz, x determines yz. Then our second normal form. A table is in 2NF if it is in 1NF and no non-prime attribute is dependent on any proper subset of any candidate key of the table. So that is a non-prime attribute of a table is an attribute that is not part of any candidate key. So it is not the part of the key, and a candidate key is always minimal super key. Super key is the subset of the key. That's why its name is super key. Candidate key is just the minimal super keys. This is one example. Library allows patron to request books that are currently out. So B3, B2, B1, B2, first column, it cannot be primary key, B2 repeated. J Fisher is also repeated for patron column. Phone number is also repeated, first two rows repeated. That's why in any problem, we have to first find out the primary key or candidate key for the problem to be solved in normalization. That's why we have to find out which one is primary key or candidate key. So candidate key is book number pattern. Why? Book number pattern combinedly it is unique, the values. But if you take individually, it is repeated. That's why book number pattern is taken as the candidate key. And we have here pattern determines phone number. Pattern determines phone number. Just see J Fisher 555 J Fisher 555 That is, we can repeated things can be written in single row. Then M Amar 555 That is another, it is uniquely determined. So first two rows are uniquely determined because they are repeated. That can be taken as one row. That's why it is candidate key. And pattern determines phone number. Pattern determines phone number because it is uniquely determining the values. Table is not 2NF, potential for insertion anomalies, update anomalies, deletion anomalies. These are the potential things. So that's why what we will do, candidate key, those are formed that is taken as a single table, and others that is forming a pattern determining phone number, that is also another table. So here it is splitted, and most few of the data are repeated previously, it is now not repeated. That's why it is some redundancy is removed. Third normal form. What is the definition of third normal form? A table is in third normal form if it is in 2NF and all its attributes are determined only by its candidate keys and not by any non-prime attributes. And it has no transitive dependency. This is the thing. This is the data. Candidate key is book number. Pattern produces or it is determining addresses. So that's why address is taken as in a separate table. So here few of the data are removed. Redundancy is removed. That's why it is so somehow better. No repetition. So here also candidate key is tournament year and 1999 is repeated. That's why it is combined. Winner determines date of birth. So then Boise code normal form. It is Tricker normal form of 3NF. A table T is in BCNF if for every non-trivial dependency X determines X is a super key for table T. Most tables that are in 3NF also are in BCNF. So example is, this one is the example. Manager determines branch. It is project branch determines manager. So not in BCNF because manager produces branch and manager is not a super key because it is repeated. So we'll decompose the work. So we will do the decomposition of the work. So manager project, manager branch. Manager is the primary. This is the idea. Then manager project, manager branch. Thank you. This is all about the normal forms from first normal form to third normal form. Thank you.